say we have a matrix. A which equals 1, 3, 0, 2, 4, 6, 0, 3, 1. So what you want to know is, does AX does matrix A times vector X equals to F always, does this matrix does have always solution. Does this equation always have a solution? And here what I mean is X is going to be three-dimensional and B is going to be three-dimensional. I have to make that assumption, right? Because if I put vector B to be before entries, then it definitely is not going to have solution. And if vector B will have two entries, it's also not going to have solution because sizes should coincide. Okay. So again, if you look at their sizes, so let's look at the dimensions first before why we have 3 by 3. So we started with 3 by 3. That's our original one, 3 rows, 3 columns, which means part in the middle should be the same. Right. Part in the same should be the same. And because we're talking about vector, vector will have only one column. So that's why 1. So that which means answer will have dimension of 3 by 1. So answer will be your B. And this guy we multiply by is going to be X. So that's why dimension of vector X is 3 rows, 1 column, and answer dimension of vector B is 3 by 1. Anyhow. So let's start working. So we write A times X equals to B. So we write in 1, 3, 0, 2, 4, 6, 0, 3, 1 times x1, x2, x3 equals to B1, B2, B3. So we're going to get 1, 2, 0 times x1 plus 3, 4, 3 times x2 plus 0, 6, 1 times x3 equals to B1, B2, B3. So finally, we have system of linear equations. X1 plus 3x2 equals to B1, 2x1, 2x1 plus 4x2 plus 6x3 equals to B2. And final. We did all that, we did all the calculations, but actually we did not need to do that, right? Because what you might have realized from square one, that we don't need all this, right? So we might have made our life much easier and say, well, we have our system to solve, and we almost immediately can jump to the augmented matrix. So you can write down, right from square one, you could have written your matrix 1, 2, 3, 1, sorry, 1, 3, 0. Right? 1, 3, 0, 2, 4, 6, 0, 3, 1, and make it into augmented by putting your answer, which is B1, B2, B3 on the right side. And you see, that is exactly what we actually got by doing the calculations. But we don't need to do that because we already know corresponding augmented and that matrix equation will have the same solution. So we might have just immediately jumped to that augmented one without doing all those intermediate steps. It's kind of nice to do it once or twice just to confirm that it works. But down the road, you kind of want to see that, augmented matrix, same as AX equals to B, and how to write it. So when you have AX equals to B, corresponding augmented is basically A. Okay, that's your augmented. And you just basically need to solve this one. To bother about that. Does that make sense? Okay, if it does, let's try to solve this one now. So I'll move on to the next page. Write it one more time. 1, 3, 0, 2, 6, 0, 3, 1, B1, 2, 3. So we take row 2 and divide by 2. So 1, 3, 0, B1, 1, 2, 3, B2 over 2, 0, 3, 1. Then we do row 2 minus row 1. So we're going to get 1, 3, 0, B1, 1 minus 1 is 0, 2 minus 1, 3, B2 over 2 minus B1, 0, 3, 1, B3. And then we do row 3 plus 3 row 2. We're going to get 1, 3, 0, 1, 0 minus 1, 3, B2 over 2 minus B1. We're going to get 0, 0. And 1 plus 9 is 10. Here we're going to have B2 plus 3 times B2 over 2 minus B1. I'll stop here because I got my echelon matrix. And from echelon matrix, I should be able to conclude whenever this one we're going to have a solution or not. So does it have a solution? Remember, in order to have no solutions, we want to run in trouble when we say 0 equals to 1, 0 equals to 3. So in order to get that, we want to have 0 on the left side before equal sign in our equations. If you look carefully here, if you look at the first column, definitely has no 0, and we cannot get 0 because we have pivot in it. We have pivot in the second column, and we have pivot in the third column. I mean, first row, second row, and third row. So no way we're going to be able to get 0 equals to 1, because when we do that, our reduced echelon is going to look something like 1, 1, 1, 0, 0, 0, 0, 0, 0, right? Something here. If needed, we calculate it. But there is no way we're going to get 0 equals to 1. So, because we are not going to get that contradiction 0 equals to 1, so we conclude that this system will always have solution. And even more so, if you carefully look what we did, then to an extent you notice that whatever we wrote here were our answer, our product. It didn't really matter. In extent, what mattered is whenever matrix A, original one, will be reduced so that each row will have a pivot. So that's basically what it boils down to. So what we want to have is, we don't want to run a problem when we have bunch of zeros before equal sign. So to avoid that situation, bunch of zeros before equal sign, we can avoid it if we have pivot. So if in each row we have pivot before equal sign, then we're definitely going to have a solution. Okay. Make sense? Then I will try to write that the next comment. Ax equals to b. This is a solution, might be the solution. If and only if when we write matrix A and we're going to get its reduced echelon form, we reduce it to reduced echelon. And the reduced echelon of A has pivot in each row. So the reduced echelon of A, we don't even need to refer what B is. So A is A1 through AN, okay, is M by N matrix. Let's see. Then the following equivalent. So what is equivalent? First one, AX equals to B. That's solution, a solution or the solution. Two, reduced echelon of A as pivot in each column. Okay. 3. For each B, B is a linear combination of vectors A1 of 1. Columns, if you take span of columns, say 1 through n, is the whole space R M. I guess maybe shortcut for when we're doing the product. Say when we wanted to multiply, say 1, 2, 3, 3, 4, 1 minus 1, 2, 0 by 1, 3, 2. We can immediately get our answer, almost immediately. So let me write it down. And then we'll look maybe a little bit more carefully and then figure out. So firstly, first entry 1 in our 1, 3, 2 vector should be multiplied by first column. So we're going to get 1 times 1, 3 times 1, negative 1 times 1. But now we do 2, 4, 2 in vector 2, 4, 2 second column and we multiply it by 3. 2, 4, 2 and we multiply it. And when we take 3, 1, 1, 3, 1, 0, and we multiply it by 2. And we can get our answer from here. Okay. If I want, for example, here, look at the, say, second column, second row. How did I get second row? So that is 3, 4, 1 multiplied by 1. So that's exactly what it's reading here. 3, 1 plus 4, 1, 4, 3 plus 1, 2. Okay. So to get, for example, second row here, that is row 2 times 1, 3, 2. To get the first one here, we do row 1 times 1, 3, 2. To get the last entry, it's row 3 from our matrix times 1, 3, 2. And we do dot product between the vectors. And dot product means you multiply the corresponding entries and add them. But to an extent, a shortcut. It's not that important at the moment because we can easily just do it. It will be more important down the road when we'll be doing multiplication of matrix times matrix.